This is 11.2.1. We're going to draw a 3D model. So we're going to examine a three-dimensional graphing system, and then we're going to plot values on the three-dimensional system. Now, in the past, we've done 1 dimensions, we've done 2 dimensions, but we have not talked about 3. Now, to give an example of a one-dimensional system would be x equals 3. That's just a number line, and we drew those. You know, especially when we had those inequalities, and you'd have to find the boundary points, and then you would test what's true and false, and then you would do some shading. That's drawing on a one-dimensional system, and we've used that. The two-dimensional systems has 2 variables. We've done that in the coordinate graph, right? That was our x-axis, that was our y-axis, positives, negatives, and we can go through and we can graph a line. That's going to be graphing in our 2-dimensional system. So now we have 3-dimensional systems, and for us to do that, we're going to have to use a 3D space to be able to represent the information. And typically, we say that that third dimension is z, x, y, z. That's why we started with x and y. And so this is what a 3-dimensional space looks like. Now, to help visualize this, think that this piece right here is the corner of the room. That's the corner of the room, and so we're coming out this way, we're coming out this way, and we can go up. So if you were to look at, like, you pause the video right now and just look at your wall, your z-axis is that crack that you see along the wall. And then coming out towards you, that's going to be the x-axis, and then going along the horizontal, that's going to be the y-axis. And there's also positives and negatives that are involved. So this here is the positive z-axis, positive y-axis, and then positive x-axis. And the way that it helps me to remember what's positive or negative is if this is actually the corner of the wall, if you're ever going into the wall or into the floor, it's negative. So if that's the corner, well, I just went through the wall, so that's negative. If that's the corner, I just went through the wall, that's negative. If that's the corner, I just went underground, that's negative. So if you're ever going through the wall, that's negative. And we label it, everything's the same, so that would be like, you know, positive 1, positive 2, positive 1, positive 2, positive 1, positive 2, right? So you just label it the same way. It's just within that 3D system, you have to imagine this axis extends on every single one of these intersections. And you're going to see what I mean by that shortly. So let's kind of plot this. We have the point 3, -2, and then 4. So that means that this is my x, this is my y, this is going to be my z. So 3 along the x, 1, 2, 3. -2 along the y, 1, 2. And then 4 along the z. Now I have to pretend that this here extends on that dot. And so looking about how much that is, so 1, 2, 3, 4. So that's going to be the dot in 3-dimensional space. Now that's weird. You're just like, wait, it just looks like I just put a dot out of nowhere. But in the 3-dimensional realm, I'll just kind of recount it with red. I did 3 in the x. I went through the wall, so that's why it was negative. And then I have to count up 4 spaces from that. And I have to imagine that this here is extending from that dot. So counting up 4, 1, 2, 3, 4. That looks about the right spacing. That's kind of, it's hanging out. That dot is just chilling out in space. And so that's how we plot on a 3D graph. Let's do another one. 2, -1, -2. So remember, x, y, z. So my x-axis, it's going to go 2. My y-axis, it's going to go -1. And then my z-axis, it's going to go -2. So I have to imagine that this is kind of like projecting downward. And so, and it is an estimate, right? That's underground, clearly. It is an estimate, but that's about 2 spaces underground. Maybe it needs a little bit more. Yeah, I think that's a little more. So this 2 space here, that's about right. So that's the point out in space. Three, 1, 3. So 1, 2, 3 along the X, 1 along the Y, and then now I need to go upwards for the Z. So 1, 2, 3. And so that's the point chilling out in 3-dimensional space. Now this is actually how we can also draw shapes. And eventually, this idea of 3-dimensional space really helps us in things like physics and things like chemistry. And the main reason is things don't move in a 2-dimensional space, right? If you're just thinking about the molecules that are floating in the air right now, they're floating and moving through 3-dimensional space. Now, how do we project where those things are going? Well, we use vectors. That's a completely different study. We're not there yet. We're not going to talk about that yet. But just know that now that we understand at least a little bit on a 3D graph, we can start modeling basically anything that moves in 3-dimensional space, which is anything that we do. So this one, a 2x2 cube. So 2x2. I'm just going to set the cube there in the corner. So 1, 2. So I have this part of the cube here. Now it has to extend up 2 spaces. So 1, right? So it's moving up the 2 spaces. If I can get that right. Now I think it's stretched a little, which is why it doesn't look like a full cube. But that's about right. And so that's, if you imagine the box sitting there in that 3-dimensional space, right? It goes along the X, it goes along the Y, it goes along the Z, and then we have our box. So in conclusion, what did we learn today? Well, we introduced 3D graphs, 3-dimensional systems, and eventually we're going to use this to be able to solve any 3-dimensional system that we do have. We're not there yet. Baby steps. Now, before ending the lesson, as a recap, what I want you guys to do is I want you to draw that 3-dimensional space and label the axis on your notes. Make sure that it's there. This does conclude our lesson. If you have any other questions, please leave them in the comments.